My talk tonight is my selection of the 12 top moons. So it doesn't include the moon. I'm actually doing a talk next month which is all on the moon. And I'll be talking about just our moon itself. So this is moons that go around other planets, so not our moon at all. So the criteria for why I've chosen some of these moons, they have to be unusual in some way, or they look so much not like the moon. There's something unexpected about them. Right? So there has to be something special about them. So none of them look just like the moon. So to give you an idea of scale, if we take the Earth and we shrink it 30 million times, we'd get a ball about this sort of size. Now, I've got scale models of most of these moons that are at the same scale as this Earth, so you can see how small or how large they are compared to the Earth. And if we shrink the moon down to the same scale, this is how large our moon is compared to the Earth. So they're at the same scale. You can see the moon's roughly the same size as Australia from one side to the other. Just to say, I've got scale models of some of these moons, and you can see when I hold them up, you can compare them to our globe of the Earth over there and see just how much smaller they are than our moon, or how much bigger they are. Now my number 12, the first one on the list, is Phobos. And Phobos is one of Mars' moons. It's only about 25 kilometres in diameter, so at this scale, I haven't got a model because it would be the size of a pinhead. So you imagine a moon the size of a pinhead compared to our moon. It's tiny. It's only 25 kilometres across. And it only takes about 8 hours to go around. Our moon takes a whole month to go around. So in one day you'll see the moon go past 3 times. If you were to stand on the surface of Mars and watch Phobos, you would actually see it move across the sky. If you watch our moon, you don't really see it move at all because it goes so much slower. And they think because it's quite small, it's actually a captured asteroid. So Mars has actually captured this rock from space that's gone past, and its gravity has brought it in and kept it in orbit around the planet. The same with Deimos, which is another one further out. Now it's interesting because it's such a small moon, it has very little gravity. And in fact, it's also the moon that is closest to its parent planet. If we had Mars here, the moon would be orbiting at about this sort of distance. Our moon is over somewhere near that door, but Mars's moon is only about this far away from the planet. And because it's so close, about half of the gravity that should be on the moon is offset by Mars pulling you off the moon, if you get what I mean. So in fact, the gravity on this particular moon is so small that if you walk down into some of the large craters, you actually get heavier because you're getting closer to the centre of that moon, and the gravity gets greater as you get closer towards the middle. So you would feel walking down a big crater that you're getting heavier and heavier. Mind you, an average adult would weigh about 70 grams. So an average adult would weigh about this much if you were standing on that moon. Yeah?
Does that moon spin, or one side always faces?
One side always faces. Because it's so close, Mars's gravity has basically held it, and it just holds it in one location. So as it goes around, it's what they call tidally locked.
So if you walk to the other side of that moon, you really have Mars's gravitation
pulling you down on the other side as well. So you'd be heavier on one side of the moon compared to the Mars side of the moon, and if you walk down a deep crater, you actually get heavier because it's so irregular and the gravity is so small. Just going different altitude changes just how much you weigh. On the Earth, you actually weigh less if you were to stand on top of that table, but tiny fractions of a gram. On a moon like Phobos, it's considerably bigger difference. So the gravity on this moon is actually 1/1000th, roughly, of what it is on the Earth. Everything that weighs 1 kilogram weighs 1 gram if it was on that moon. So you could pick a car up in one hand would weigh 1/1000th. It would weigh a kilogram. You could pick it up easily. There, notice on the surface of this moon, there's these big long lines, and they traverse a large part of the surface. Now, what's caused these is a meteorite has hit Mars at some time and it's thrown material up into space. And because Phobos, as I say, is at this scale, it's only this far away, some of these rocks are thrown up so high that Phobos has ploughed right through the middle of all this material that's been thrown up from an impact. And it's created these long, almost like scratch marks. Actually, if you come to my talk in a couple of months, I'm talking about this. There's actually some people think that this moon is a derelict spaceship. But that's another talk in a couple of months' time in August. Yeah?
I was actually reading a book that two meteorites crashed into each other and that made the Earth. Is that true?
Well, they weren't really meteorites, but they believe that what they call a protoplanet, something around about the size of Mars, hit the Earth billions of years ago, and when it hit the Earth, the material that was thrown up became the moon. Most of that material was from this object, which is about this sort of size, hit the Earth billions of years ago, and most of that material is what made the moon.
Is that what killed the dinosaurs?
No, this is billions and billions of years before the dinosaurs. The thing that killed the dinosaurs at this scale is about the size of a pinhole, right, compared to something about that big. Yeah?
Was there any people on the planet?
There was nothing, absolutely nothing. There wasn't even water.
Well, then how did we get them?
Well, we had a lot of time. We had billions of years. Yeah?
You know how on Phobos, you could lift your car up with one?
Yes.
Could you lift a truck up with two?
Well, if you take the weight of a truck, divide it by 1,000, however many tonnes it is on the Earth, that's how many kilos it would be. So if it weighed 50 tonnes on the Earth, it would be about 50 kilograms on the Moon. Of course, you've got to get the truck up there. So it's a very expensive science experiment, so we won't actually do that tonight. Now it's interesting, I checked the current launch date for this. They think it's still around about December of this year, December 2011. Russia hopes to send a probe to Phobos. It's called Phobos Grunt, which is a sample return. What they actually have is this probe, and you can see this is a mock-up of it. You see how big this thing is, right? So it would stand about this high. It would fill up most of this room. And what it's actually going to do is take some soil from Phobos, shove it into a rocket, and fire it back home. So say the current schedule is they're still hoping to launch this in December. It'll take about 8 or 9 months to get there, so it could be the end of 2012 by the time it gets there. Maybe 2013 by the time this rock comes back, about 100 grams worth, so about that much soil from the moon they hope to return. I don't know who was first. We'll go from the back and go forward. Yeah? You're first? Yeah? You?
If they shot the rocket back, where would it crash?
They're thinking they might have to put it into an orbit around the Earth and then get something to go up and get it.
So sort of like
They'll put it in what they call a transfer orbit because they don't want it to come crashing to Earth uncontrolled in case it has any dangerous bacteria on it. It's unlikely it does because they haven't discovered anything. But they might put it into a transfer orbit and then they'll send a probe up that'll pick it up and then bring it home, basically put it inside something and then bring it down. Yeah?
So I've got to bring a rocket ship up and then
And fire a little one
land
back.
it.
so
Yeah, they're going to land this onto that moon and then they'll fire another rocket back. It's about the size of that water bottle there and that'll have Mars or Phobos rocks in it and then they'll send that back to Earth. Yeah, you are the next.
If they fire that probe that's on that screen now up to the like Mars or
Yeah.
the moon because I wasn't really.
Yeah, Phobos was going to. Yep.
Is it gonna fire like a little rocket back filled with stuff? And when is the time for when that has to come back?
It'll come back, as I say, because it takes about 8 months to get to Mars and 8 months to get back at the quickest. So it would be 2013, 2014, something like that, before it would actually come back with the sample. So it would be 4 or 5 years' time at least.
And also, where did you get that dot to
That,
It's cool.
it's a presenter.
It's cool.
You can get them at Dixon and stuff. Yeah.
Would that thing stay on Mars?
No, this is going to land on Phobos. So this will
Will it
land
come
on
back?
the moon. No. Far too much fuel. See these big cylinders here? They're all fuel to get it there. You would have to have even more fuel if you wanted to get it back. So it's easier to just leave it there and fire a rocket this big to get back home. I'm going to have to stop answering questions all the time because I'm only on number 12.
You don't need 1,000.
We've just got a long way to go. Yeah.
Guys,
So
we
you
might
want to get
ask-
to the same sort of speed.
We might ask questions at the end of the course, yeah?
Yeah, otherwise it's just going to, we're just going to continue on. You can ask questions at the end. Because
Save your
otherwise,
questions to the end.
yeah. Unless you've got something really important to ask, then you can. But otherwise, I'll allow you one question and then that's it. Yep.
So a rocket ship has 1,000 gallons of fuel to get over to the moon, but
Yes.
if you say that can't get over to the moon and back, how is the rocket meant to get back?
Because it's very, very small, right? It takes huge tanks, this big full of fuel. That's only to land it. There's a whole rocket, bigger, many times bigger than this building, to get that to that moon. That fuel is just to land it on this little moon. When you've got a rocket that's this big, you still need quite a lot of fuel. You might need maybe that much fuel to get this little rocket off the ground, off Phobos, but it takes a lot of fuel. You see, those cylinders hold a lot of fuel, and that's just to land.
Yeah, if that little rocket keeps on orbiting around Earth, what happens if that runs out of fuel when it's
It doesn't need to. It just keeps orbiting. It doesn't need fuel. Once it comes in, if they get the trajectory right, the Earth's gravity will grab it and it'll stay there. And could orbit for 10 or 20 years, and then they fire a rocket up and they grab it. A lot of satellites only need very minimal fuel to stay up there, because otherwise it's just too expensive to get all that fuel up there.